Welcome back to the deep dive. Today we're tackling something that, well, it gets a lot of people worried: Yellowstone's earthquakes. You see the headlines, right?
Absolutely. And our goal today is to really dig into the data, decades of it, from reliable sources like the USGS and the University of Utah.
Okay.
We're looking at counts, sizes, energy, those same as swarms.
Mm-hmm.
Basically asking, is Yellowstone actually getting seismically busier? Or is something else going on?
Let's jump right in then, because it really does seem like we hear about Yellowstone shaking more often. Why is that perception out there? Is it real?
That's the million-dollar question, isn't it? And largely, it's a bit of an illusion.
Yeah.
It stems from massive improvements in how we listen to the Earth there.
Better listening. How so?
Well, the Yellowstone Seismic Network, the YSN, got a huge upgrade around 1995, went digital.
Mm-hmm.
And it's been getting better ever since. This dramatically lowered what seismologists call the magnitude of completeness, the decay. Think of it like turning down the static so you can hear even the tiniest whispers. We can now reliably detect much, much smaller quakes across the whole park.
And the numbers reflect that, right? I mean, the raw counts jumped massively. Weren't they like maybe 200 a year before 95?
Exactly. And after that, it shot up to, 1,500, even 2,500 quakes detected per year.
But then there was that AI study in 2025. Didn't that find even more?
Oh, absolutely. That was fascinating. Using deep learning on data from 2008 to 2022, it uncovered over 86,000 earthquakes. That's like 10 times more than previously cataloged for that period.
Wow, 10 times.
But here's the crucial point. This is a technological leap in completeness, not a geologic leap in activity.
Right, so the tiny quakes were always happening.
Precisely. We just couldn't hear them before. Now we can.
Okay, that makes sense. It's about detection, not necessarily more shaking overall. So if we adjust for that, if we filter out those really tiny quakes we couldn't always detect, what do the actual long-term trends show?
Yeah, when you normalize the data, say you only look at earthquakes magnitude 2.0 or maybe 3.0 and above, quakes we could reliably detect even back in the 70s.
Then what?
Then there's no statistically significant upward trend in activity. None. From 1973 right through to 2025.
So the overall rate for quakes of a certain size is pretty steady.
That's right. The annual counts, even recently, fluctuate between maybe 700 and 3,400. But that's well within the normal expected range for Yellowstone over the decades.
And there's other evidence for the stability, too.
We look at something called the Gutenberg-Richter B-value. It's basically the ratio of small earthquakes to larger ones.
Okay.
And that B-value has remained really stable, around 1.0 to 1.2. That's typical for places like Yellowstone, where you have both tectonic faults and volcanic processes. It tells us the underlying stress in the crust isn't fundamentally changing in a way that would suggest, more large quakes are imminent.
And we haven't seen a really big one in a while.
Not within the park boundary, no. The biggest quake that really dominates the energy release history was way back in 1975, a magnitude 6.1 near the Hebgen Lake Fault Zone just outside the park. Inside the caldera region itself, there hasn't been an earthquake of magnitude 5 or greater since 1994.
Okay, that puts things in perspective. Stable overall rate for moderate quakes, stable stress patterns. But what about those swarms? They get a lot of attention. They feel like spikes in activity.
They definitely do cause spikes in the number of quakes detected, absolutely. And swarms are, they're actually a totally normal part of Yellowstone's personality. They account for about half of all the earthquakes recorded there.
Half. Wow.
Yeah. But importantly, when we look over the long term, there's no clear sign that these swarms are becoming more frequent or more intense.
So like a big swarm now isn't necessarily bigger than one decades ago.
Exactly. Take the 1985 swarm that had about 3,000 events. Then the 2017 swarm had over 2,400. Comparable sizes, but more than 30 years apart. There's no obvious accelerating pattern.
And what's actually causing most of these swarms? Is it magma moving?
That's what often worries people, but typically, no. Most Yellowstone swarms, the vast majority, seem to be driven by changes in hydrothermal fluid pressure, basically. Hot water and gases moving around in the crust's cracks, not magma on the move towards the surface.
Right, so it's more like the plumbing system creaking and groaning, not the volcano clearing its throat.
That's a pretty good analogy, yes. It's part of the dynamic hydrothermal system that feeds the geysers and hot springs.
Okay, so stepping back, better detection explains the apparent increase, but looking at consistent data shows stability. Swarms are normal, mostly fluid-driven, and not increasing in frequency or intensity.
That's the picture the long-term data paints. Yellowstone is seismically active, yes, but it seems to be humming along at a fairly consistent pace, as it has for decades.
So our deep dive confirms it. The seismic activity seems stable, not escalating in some alarming way. The noise was largely us getting better hearing aids.
Which leads us to think, doesn't it?
Mm.
What does this consistent long-term rhythm of Yellowstone actually teach us about how these huge dynamic supervolcano systems behave?
They're active, yes, but also possess a certain stability over human timescales.
Mm.
And maybe more importantly for you listening,
Yeah.
how can we use this kind of deeper understanding, looking past the raw numbers, to cut through the sensationalism and really grasp what's happening, or perhaps more importantly, what isn't happening?